Well, it's going down very slowly, and it's still doing this sort of pulsating sort of drain. So that's going to be very interesting for the double flush, but as you can see, no sand really coming out. So the idea that the newspaper sailors will hold back the sand, even though you've got the slot there, means you've got less work. You don't have to cut off, you don't have to buy fly wire, you don't have to cut fly wire. So time and money you've saved on that. And and sand is cheap, of course, but it could also be that the sand might be salty if they're digging up from the beach, and also the newspaper sailors might be salty. So it might explain why this is taking 3 weeks to take off, because around the walls of the side of the container it's harder to flush through something that's as a cylinder on the side, you see, whereas if you got something like this that's thoroughly throughout and also opened up by the sand, it would be easy to flush any salt that's in the newspaper cellulose as the cat litter to keep it fresh, I suppose, or stop it from going off. It's easier to wash out, so we might get a faster reaction from this. It may only take 2 weeks for the greening to occur, but again, we might have competition between the phenolics and other stuff coming down from the brown wood meeting the stuff coming up, and there may be competing effects. So it may inhibit the greening, I don't know. It could also enhance the greening, I don't know. But we're going to find these things out. But as I said, after a while, we'll pull back the coir after 2, 3, 4 weeks. We may actually do it on a regular basis and see if the sand's gone totally Albion, and if it loses that Albion look in about 10 minutes. As I said, that's the shock I got with this. It was whiter than that, and it lost that sort of white look in about 10 minutes of being exposed to the air, basically. So this is good, the fact this is slow dripping, because it means it's going to be more, in quotes, microaerophilic to anaerobic sort of thing. And also because it means it's also going to be holding more water for longer, so it's going to be cooler for longer, and that may be important if the organisms involved are on the psychrophile end of the scale. You know, they like the cold rather than the warmth. They're not extremophiles in the upper echelon. They don't like a warm day, they like a cool to average day or something like that. So yeah. But it would be strange that we're in the country with the most sun dew anywhere in the world, and we're a hot, dry, flat, windy, dusty continent, very shrubby. But then again, we have this vegetation called sclerophyllous vegetation, and we're the one country in the world that has the most of that. Africa has it as well, but we have the most. It's really predominant here, so that may have something to do with the way things work. The breakdown of the sclerophyll. We may have to investigate that. Once we've gone from the bark chips and the coir, we may actually have to go into collecting sclerophyllous bark. It's very hard, and investigate the Aussie ecosystem for forms of carbon and wood, basically, and see what happens. So anyway, basically that's come down. You can actually, it will, as you can see here, it will actually, it's holding water, and you can actually see it will actually lose a little bit more water and go down. And that will allow us to put our, from experience, if that goes down another ½ an inch, it should be enough to cope with our, when we get it, litre of coir when I get it set up. So that'll be the next clip. Okay, over and out for now. See ya.